Usually we have a polynomial of order 2 that we're trying to find the roots of. And a lot of people turn to the quadratic formula, which looks like this, that x is equal to, minus b plus or minus the square root of b squared minus 4ac, all that over 2a. Right? Issue is that to remember such a formula is kind of requires a bit of rote memorization, but it's good to know where this comes from. So I'm going to use a method called completing the square to prove it to you that this is actually true. Completing the square. All right. So the first thing I'm going to do is make the polynomial monic. Make the polynomial monic. Which just means that the highest order value of x is going to be have a coefficient of 1. Right, so the way we do that is we just divide through by a. So we go x squared, b on a, x plus c on a equals 0. And obviously 0 divided by a is 0. From here, we're going to now do the completing the square steps, which is we just set 2 alpha is going to be equal to b on a, and then alpha is going to be equal to b on 2a, and then alpha squared is going to be equal to b squared on 4a squared. Now what you do is you add and subtract both that number. So if I add some alpha squared, and I also subtract alpha squared at the same time, I've essentially added 0, so I've not really done anything, which is the idea behind this. So we're not really changing the equation at all. So b on a x plus alpha squared, which is b squared on 4a squared, and then we have, I'll put plus ca there just so we can separate it out, and then we just minus off that same thing that we just added. And it's just a constant, it's not a variable, so we're not breaking any major rules. Hopefully I can just move that over a bit. Okay. From here, we just sort of have to understand the form of what we've just done, what we've just created. So if we have x plus alpha, what you end up with is squared, you end up with, if you expanded x squared plus 2 alpha x plus alpha squared, right? Well, what is alpha? Alpha, we've just said here, is this, and then we have alpha squared as this. So we've actually got 2 alpha there, and we've got alpha squared there. So we actually have and then we still have plus c on a minus b squared 4a squared equals 0. So the idea is to create that perfect square and have something on the outside that isn't part of that sort of factorization. Cool. Now let's move this stuff to the right hand side and substitute our value in for alpha. Alright, and that's squared, sorry. Then from there, we're just going to turn, we're going to turn this into one fraction, sorry. And so let's just write this side out, so that's done. And then we're just going to times by 4a on top and bottom over here, so timesing by 1 essentially. B squared minus c times 4a over 4a squared, and then we get x plus b on 2a. We'll just do it here actually, save us writing it out again. And then we get b squared minus 4ac on 4a squared. Okay, so starting to get some part of the form of the quadratic formula up here. So we get in here. I'm going to take the plus and minus square root of both sides. So then you get plus or minus square root of b squared minus 4ac over 2a. Oh, sorry. Getting ahead of myself. Over 4a squared. And if you recall, if I do the square root of w over v, that's actually equal to the square root of w over the square root of v. That's a bit of a funny square root sign, but whatever. That's just due to the way that exponents distribute. And we know that if we have a over b to the power of c, we get ac and bc. And then here, for this case, c is just equal to 0.5, right, for a square root. So it's the same thing we're used to. Then, if we think about what is the square root of 4a squared, that's just going to be 2a. And then we end up with x plus b on 2a is equal to plus or minus 1 on 2a, and then the square root of b squared minus 4ac. And then we bring over that little last term next to x. So x is going to be equal to minus b on 2a plus or minus 1 over 2a square root b squared minus 4ac. And then if we have a plus or minus, you might be, well maybe not, but just in case, you might think, okay, we've got this 2a on the bottom, but we've got this plus or minus between it. Does that really mess with us? Well, if we just go y over 2a plus or minus z over 2a, like just to do a little experiment about what those two solutions will be, well, the plus will give us y plus z over 2a, doesn't affect the denominator, and then y minus z will be 2a as well. So we can just put the plus or minus on the numerator and not worry about it. And then we get that, which is the quadratic formula, right? So that's how completing the square, that actual, I guess you could call it a trick, but maybe a technique would be more accurate, can help you find roots, but not just any roots, not just the roots of some particular equation, but any equation, and that's where the quadratic formula actually comes from. Hope that convinces you to perhaps get used to completing the square. Until next time.